There are lots of ways to work this. I worked it one way, the solutions that I got has it another way, and then if we work it together a different way, it should all get the same answer. So let's just try to work this together, and I am open to suggestions. We have an electrical load operates at 240 volts RMS. The load absorbs an average power of 8 kilowatts at a lagging power factor of 0.8. Calculate the complex power of the load, calculate the impedance of the load. Okay, so do either of you want to make a suggestion as to what you would like to do? There are lots of ways you could go about doing it.
For D, we just do P equals the VRMS squared over the impedance?
Well, did I write power or did I write complex power on the last one? Did I mess up? I said average power. So the complex power is, so the power, the real power is VRMS over the resistance, VRMS squared over the resistance. The complex power is VRMS squared over Z conjugate. Let me see, could we do that here? So we have elect the load. Okay, yeah, it only gives us average power. We don't have complex power yet. Yeah. And I think that's what you said, and I just was not processing quickly enough. So what we know is that the real power is 8 kilowatts. We have, our voltage is 240 volts. And we can say angle 0, and we'll measure everything else with that. We know our power factor is 0.8. So the way I would do this, and this is not necessarily the way that you're going to do it in class, but I think it's easy, and it's the way you do it in power class where you're going to do power, is that we know that the cosine of theta, that's what the power factor is 0.8. So theta is the inverse cosine of 0.8, which is 37 degrees. Now, is it going to be positive 37 or negative 37?
Doesn't matter.
It does matter because it tells us right here, lagging. So which one is it? Positive because lagging. So then we can say our real power is 8,000, and then we have our reactive power, and we have our apparent power. We have that this is 37 degrees. So we know that 8,000 equals our apparent power times the cosine of theta. So this side equals S cosine theta. And we know cosine theta is the power factor. So that's S times 0.8. So S equals 8,000 over 0.8, or S equals 10,000. So our apparent power is 10,000 volt amps. So then how do we get our reactive power?
S sine 37?
Mm-hmm. So Q equals S sine 37 degrees. our Q equals 10,000 sine 37 degrees. And this was set up, this is a 3, 4, 5 triangle, if you recognize it. So that's 6,000 VAR. Let's see, now why did I do that? Oh, because it said calculate the complex power of the load. And so now I have it. I have that S is 8,000 plus J 6,000. And I also know it's going to be 10,000 angle 36.8 degrees, 36.9 degrees. Yeah, it would have to be that angle. VA. Okay, so now we can calculate the impedance so I see how I did it. Let me see. I don't always do things in the most effective way. See if there's a easier way. Seems like we ought to be able to do it. I did it in a longer way, but like just to do what I was just talking about and to practice doing it, it seems like that ought to work. So let's see if it does. So this would tell me that Z conjugate would equal V RMS squared. So V was 240 angle 0 squared over S, which was 8,000 plus J 6,000. And I'm missing 1,000 in there somewhere. Or maybe I'm not. Where's my missing 1,000? It's 4 plus 6, yeah. It's supposed to be. Did I forget to square it? I forgot to square it. Yep. 4.6 minus J 3.45. Now that is Z conjugate. So what is the impedance?
4.6 plus
Plus J 3.45 ohms. Now, the way I did it was a longer way, but just to try it out and see that it works, we know that S equals VI conjugate. We know that S was 8,000 plus J 6,000. We know that V is 240 times I conjugate. So I conjugate is 8,000 plus J 6,000 over 240. So I get that I conjugate is 41.67 angle 36.86 degrees. So I is 41.67 angle negative 36.86 degrees. And then once I have I can say that V equals IZ, or Z equals 240 over 41.67 angle negative 36.86. And I get 4.6 minus 3.45J, which should be the same answer that we got before, except needs to be conjugated. Why is it conjugated? But I don't think you have a conjugate in that one, because we've been using that one all semester without a conjugate.
In the previous one, we didn't have a conjugate.
Right. Oh, it's because I did it wrong on my calculator. Yeah, I did it wrong on my calculator. Yeah. I should have, so on my calculator I found I star, and then when I did this I did 240 divided by answer, and I should have done 240 divided by conjugate answer, and there is a conjugate in the complex menu. So like if I did, let's see, so if I do so this is what we did to find I conjugate, except I didn't do that right. What was I supposed to do? Oh, maybe that is right. Okay, yeah, it is right. Okay, so, but that gives me the conjugate of the answer. And so then I just changed the angle yeah, on my own. but then I forgot to change it when I went back and to do the 240 divided by it. So what I should have done was 240 divided by second complex conjugate second answer and then I get the right answer. Okay, so any questions on that one? All right, stop this one.